Well, I'd like to welcome everybody to our session today, Architecting a Data Lake on AWS. This is Jerry Chia, your host today. Thanks for joining in. If you have any questions, feel free to use our Q&A panel on the right side of your screen. Just look to the bottom of that panel, type in your question, and click the button to the right. If you have a specific partner you have in mind for that question, please feel free to include that in the question that you ask. That way we can direct that question. Again, you can ask questions throughout our session today. We will have a Q&A at the end of our call also. So this time we'll go ahead and hand the call over to Rahul. Rahul, please go ahead.
My name is Rahul and I work as a solution architect with Amazon Web Services. Joining me today we have Mark Schreiber, who is General Manager at Cloudwick. Along with Mark we have Raja Sheikh, CTO at North Bay, and Mick Bass, CEO at 47 Lining. In today's webinar, we are going to talk about the benefits, the value of building a data lake on AWS, and our partners will help describe some of the features or advantages you can achieve by building a data lake on AWS. Let's go quickly through the agenda. The first thing we're going to do is define what is a data lake. The second point we're going to say is what are the benefits you can get from a data lake as compared to a traditional data warehousing or a data analytics architecture. The third point we're going to talk about is why should you or how could you deploy a data lake on AWS quickly and get the benefits from the data lake. And then we'll have each of our APN Big Data competency partners talk about these benefits in detail, that how you could achieve those benefits by partnering with our consulting partners today. And in the last, we're going to summarize everything and talk about what are the things you could do to getting started with a data lake on AWS. With that, let's just get started. So before we get any deeper into the webinar or talk about data lakes, the first thing we need to do is establish a ground framework for what exactly is a data lake. Many of us have worked in the data warehousing industry or the data processing industry where we have been using a traditional databases for most of our analytic needs. A data lake is a new way given the challenges we are facing in terms of increased velocity, volume, and variety of data to handle with those kind of situations. And not only that, but to store data in a format the way it originates without worrying about what is that you need to answer from a data perspective. In the earlier times, we had to think of data as the way the questions we want to answer. And then we used to fit the data into a schema so that we could answer the questions. Not only that, with storage and compute traditionally being very expensive, we even had to cut down on how much of data we could store. Data lakes help you deal with that by giving you a centralized repository, by giving you a way to access all of your data and apply multiple types of compute on that. To reiterate, if you think about it, these are the challenges which organizations, which customers have been facing with data lakes in past, and that just is how do I collect my data quickly? We don't want to do a ETL process to collect data, for example. And if you look into each of these questions in a deeper meaning, let's start with the first one, which is what are the benefits of building a data lake in general? The first thing you can imagine is that in a traditional architecture where you collect your data from many sources and then you do a processing on top of it, which has been defined as ETL, extract, transform, and load, to fit into a schema. That process itself puts a burden or puts a cap on how fast you can ingest data. But with data lake, where you're storing your data into not a predefined schema, but you're storing data as is, you don't need to go through a ETL process which may curtail on how fast you can ingest data. Not only that, a data lake provides you a way to ingest data from sources such as real-time streams, traditional databases, or even sources such as log files and other IoT sources. If you think of the second part, which is in a traditional architecture, you distribute your data into many different stores, data warehouses, operational data stores, data marts, and etc. And that puts another layer on top of how your customers, how you guys could access data from these sources. The main question remains is that where should I go to find what data? How do I know where is my single source of truth? But if you look at a data lake, then what data lake provides you is an ability to store all of your data in a single repository, and then each of these processing or each of these data stores like ODS, data mart, or data warehouses can be thought of as projections on top of your data. So you get a single version of your data from that very definition of a data lake. The next part is, which we mentioned earlier also, was historically, traditionally compute and storage has been expensive. And not only that, the storage and compute were tied together, which means that if your data is scaling up, you need to scale both the infrastructure, and even if you're not using the entire of the compute on a given platform, you need to still keep up with the storage. And that means there was a not optimization you could do. But with the data lake architecture, where it allows you to separate the compute from storage by using, for example, by using Amazon S3 as a storage platform, you don't have to worry about scaling your storage. The platform itself scales with as your data grows, and then you can apply compute which is transient. And this model gives you a much more cost optimization, a much more efficient model for processing your data at any scale, versus a traditional scale where you have to scale up a database and both the compute and storage are tied together and they grow hand in hand. The last one, what we're going to talk about, is that in a data warehousing world or in a databases world, the only type of compute you do or the only type of processing you do is based on a SQL or based on a query of data. If you wanted to do some different kind of processing, for example, let's say deep learning, machine learning, predictive analytics, you had to either get the data out of it or rely on those databases to provide you that feature to run those kind of models on top of data. But with data lakes, you don't have to do that because your data is separately stored into a single storage, and then you can apply any sort of analytics, be it predictive, be it querying the data, be it running machine learning algorithms, or any type of processing, such as even MapReduce or Spark processing on top of the data set sitting in that data lake. And that gives you the flexibility, that gives you the ability to democratize the data within your organization. So any different kind of audience, different kind of professionals can access the data in the way they most are familiar with. And those are some of the benefits you could get by building a data lake. But once you understand what are the benefits of a data lake, the question remains is just storing data natively in its own original format, is that what defines a data lake? The argument to that would be no. That's just storing a data into a centralized repository does not constitute a data lake. You have to think in terms of what are the features, what are the ways you can ingest data into that storage. How do users find your data? How are they going to search about it? How do I know that what kind of data I have inside the data lake? What are the business meaning associated with the data lake? You have to think in terms of securing and protecting that asset, because data is the most valuable asset, and you have to ensure that that people who are entitled to access the data will get access to only that data set. For example, it may mean that a marketing department has only to the data sets about campaigns, about other marketing links they have. And finally, the last one being is that how do users access the data set? With the choice of different variety of analytics tools, with the choice of variety of different APIs, you have to ensure that people could access the data into any format, whether it be from a user interface, whether it be from APIs, or from any other method which you see is appropriate from a consumption perspective. These are the at least four important components you have to think about holistically when building a data lake. So if you really deep dive about building a data lake on AWS, and if you think from those four perspectives or those four components of building a data lake, Amazon S3 provides you as a central storage platform where you don't have to worry about putting your data into schema, or you don't have to worry about scaling the Amazon S3 storage, because Amazon S3 scales as your data grows automatically. But from the data ingestion perspective, we have services such as Amazon Kinesis, both Streams and Firehose, Direct Connect, which allows you to use your own proprietary protocol or any other software you want to transfer data from your on-prem back to AWS. Snowball, AWS import-export Snowball, which allows you to move large quantities of data much easily. Or services such as Data Migration Service, which allows you to copy or replicate data from your on-prem databases or even databases running into AWS back to your database or like Redshift, for example. On the catalog and search side, you could use DynamoDB as a central catalog. DynamoDB has integration with Lambda, where anytime you put an object in Amazon S3, it can trigger a Lambda function which can create an entry into a DynamoDB to keep a catalog of the data set. In the same model, you could also take the subset of data and pull it through a search system such as Elasticsearch, for example. And AWS provides you a managed Elasticsearch service where your users can find data based on business context. So they can search the data in any way they want and be able to find where the data is within the data lake. Regarding the management, you could use API Gateway to build APIs for people to access the data set. Amazon Cognito user pools could be used to manage the control on who all can access the data lake. And then regarding protect and secure, you have, in addition to what S3 provides, for example, server-side encryption, client-side encryption, bucket policies, you have features such as security token service, where a simple token could be used to provide a temporary authentication or provide temporary access to the data set or data in the data lakes. CloudWatch and CloudTrail could help you monitor what's going in, who is accessing it, what are the latencies, what are the metrics around that. And finally, key management service, which allows you to encrypt the data or create your own data keys to encrypt the data sitting in the data lake, could be thought as another way to protect and secure the data. You could control who can access the key to the encrypted data. So the only people with the right entitlements can access the data and decrypt it to running any sort of processing or analytics on top of it. Talking about processing and analytics, you have machine learning, QuickSight, EMR, Amazon EMR, and Redshift, and they all work with the central storage or the data that is sitting in data lake. You don't have to build any specific integration. All of them automatically allows you to take the data in data lake and run the appropriate algorithm or processing framework on top of the data sitting in S3. So why would you build a data lake on AWS? We talked about these are the ways you could build different components of a data lake in AWS. But if you look holistically, AWS provides you different features. For example, flexibility and agility in terms of on-demand resources, in terms of not worrying about managing the infrastructure. But we also talked about security and compliance, and the most complete platform for big data analytics by giving you services such as Redshift for data warehousing, Amazon EMR for managed Hadoop clusters, machine learning, and even QuickSight for quick visualization of data. So if you take a look further into why build a data lake on AWS in terms of flexibility and agility, the first we talked about is that you could store all of your data in a very cost-effective manner on Amazon S3. Amazon S3 on a normalized rate costs you 3 cents per gigabyte per month, which translates to $30 for a terabyte for a month. Not only that, Amazon S3 has integrations from Firehose, from AWS import-export Snowball, from services such as Direct Connect or S3 Hadoop Disk Copy, which allows you to move data over Direct Connect back into AWS. It allows you to separate your compute from storage and eliminates the challenges when you have to convert data into a predefined schema. S3 is the way you store the format you choose to store data in S3 is not important to S3. S3 everything treats as a black box object, so you don't have to worry about translating your object into specific format. With that, I would like to now invite Mark Schreiber from Cloudwick to talk about the benefits you could achieve from AWS in building a data lake. Mark?
Thank you, Rahul. It's a pleasure to be here and on today's webinar. I'm Mark Schreiber. I'm General Manager at Cloudwick. What I'm going to talk about today is, I think, probably one of the most important things that's facing the enterprise IT and line of business today, and that is simply, how do we leverage the cloud to transform our business? Interestingly enough, just the other day, IDC reported that they believe that we are now at the dawn of the digital economy. And this has really been Cloudwick's focus for the last 6 years. We've been working with leading data-driven enterprises to transform their traditional data center applications into big data and open source cloud businesses. What I'm going to talk to you today about is a story about an enterprise, probably much like all of you, in which they had really smart solution architects, they had really good developers, and really good data engineers. And in their journey, they recognized that AWS was the right place for them to transform their business and build a data lake business. And they were able to get there on their own in terms of their first phase POC. But I'm sure, like many of you, when you look at the challenges, the options, the different software packages that put together and make up a data lake, it becomes really complicated to optimize it for business. So one of the things that we're focused on here at Cloudwick is helping both the enterprise line of business and IT do more with their data lake, whether it's building a new one or optimizing an existing one. So in this use case, I'm going to talk a little bit about a healthcare company, and I think it's probably very similar to all of you, in which you have your line of business, looking at ways in which they can drive new digital revenue and how can they become more competitive. And I think this is one of those interesting things that we're all challenged as solution architects and developers. When we look at the traditional business models that we had, it was really a packaged software market. And we would go out to an SAP, to an Oracle, and they would tell us exactly what the capabilities were of a platform, of an application. And where this has all changed, and what is so unique about AWS, is it really transforms the IT and business model, because now you're able to leverage infrastructure as a service as well as platform as a service to build very unique and highly competitive and differentiated software analytics as well as business services. So like I indicated, one of the challenges that this healthcare company had was their solution architect and engineering team was able to start and create their data lake. However, they ran into some problems with regards to the performance of their data lake. And I'm sure this is something that many of you face. And what we really did there for them, if we look at in terms of the solution, we consulted with them based upon the experience that we've developed working with the Fortune 1000 for the last 6 years with both open source and cloud technologies to build an optimized cluster. Because the interesting thing that you'll find when you start working with these technologies is that although the options almost seem endless, there are really key and fundamental strategies for making them both performance driven but also cost optimized. So in this case, the Cloudwick solution, after doing the analysis in our phase 1 where we aligned the business and technology requirements, their POC data lake was not able to ingest the data fast enough. And they really needed help with re-architecting to create a business model in which their data ingestion could process the data in real time and thereby deliver real-time analytic results. In doing this, we had to help them with a new data governance process. We had to look at predictive analytics and the range of options that they could use, both open source and proprietary. At the end of the day, we were able to help them improve their metadata management, which frankly becomes one of the most important pieces in a data lake strategy for an enterprise. Also, what was interesting about this, years ago you would hear, and even 6, 9, 10 months ago, you'd hear things like, oh, healthcare, finance, regulated industries are never going to move to the cloud. Well, the reality is, if you look at Cloudwick's enterprise customers, we have leading healthcare and banking and insurance companies that are building their next generation data lakes on AWS because of the flexibility and the power it actually gives IT and business. So, here again is kind of the complexity if you're in IT and you're looking at the AWS landscape. It's absolutely amazing in terms of the options that it provides you. There are so many different storage strategies. There are so many different compute strategies. If you look at it from a platform perspective, you've got both open source commercial solutions from leading Hadoop vendors like Cloudera, Hortonworks, MapR. You have NoSQL options from MongoDB, as well as Cassandra and DataStax. And then you have advanced analytic solutions from companies like Databricks. And at the end of the day, the real complexity here is, and the opportunity for IT is, how do I take this amazingly powerful portfolio of infrastructure and platform applications and build my next generation business? And so in any event, just to give you some feedback in terms of what we did do, the existing data lake that they were using, they had developed based on Scoop for the data ingestion process. They were moving the data from a MySQL sharded environment to a Hadoop environment. The problem they had was, yes, this functionally worked. However, it took more than 48 hours. And the company had to wait until weekends to conduct ingestion due to the lengthy data ingestion process. This meant that it had no near real-time analytics with which to make crucial healthcare and business decisions. So, they hadn't really improved their business position. They had designed a data lake that was going to provide them with the next generation analytic and business services, but they really needed help to come in and optimize it. How do I now engineer it such that I can meet my business objectives? So we re-architected this to move to a transient Amazon Web Service EMR Spark cluster solution. And this, again, requires a lot of sophistication and skill to do. And so if you look at this, and I think you're going to see many other different architectures, I think the one thing to take away from this is that there is not one data lake architecture that fits all business solutions. And at the end of the day, what we see is an incredible opportunity for IT and business to collaborate to build their next generation business analytics and applications on AWS, simply because you can't find a better platform to build that next generation digital business. So from there, I'd like to turn it back over to Rahul and look forward to questions.
Cool. Thank you. Can you guys hear me again, Jerry? Okay. Awesome. Thank you, Mark. So now we're going to talk about what security and compliance, which is another benefit of building a data lake on AWS. First of all, anything you run on top of AWS runs on the top of secure AWS infrastructure. What it means is that we take care in ensuring that we meet the compliance and the regulatory needs for whatever workload you are running on top of AWS. For instance, it could be something as PCI DSS or HIPAA or FedRAMP from anything below the infrastructure, below the host level. But you as a consumer have features available. For example, you can enable encryption with S3 by checking a bucket, by checking an option to saying that, hey S3, encrypt all of my data before you store it in S3. Or you could even pass your own encryption keys to Amazon S3 to say that, take this data set and take this key and encrypt the data set you store in S3 using the key I'm providing it to you. And that key could be stored further, as we mentioned earlier, into the KMS service. So that allows you to create multiple keys for storing data sets in a much more secure manner. Not only that, we have services such as Redshift and EMR, which support security both at rest and in transit. And S3, when you access any objects from S3, by default, we use SSL, which means that your data is getting encrypted in transit itself. Further, from a compliance or security perspective, you could even manage your user groups using AWS Identity and Access Management and take advantage of services such as Cognito or Amazon Secure Token Service to not deal with passwords and usernames anymore. And you can just provide users with access to temporary tokens or session tokens, which they can use for a limited duration to do a very specific thing. For example, you could say that a user is only allowed to access this data or run only this API, for example, only to read the dataset in S3, but they're not allowed to write anything in S3, even at an object or a prefix level. And to talk further in details about that benefit, we'll invite Raza Sheikh, who is CTO at North Bay. Raza, over to you to talk about security and compliance with data lakes.
Thank you, Rahul. Hello, everyone who joined today at the webinar. North Bay is a 200-person growing APN partner with advanced consulting status, and we've been implementing data lakes on AWS since 2013, in that we were one of the first to achieve the big data competence in this space. We provide services to our customers building data lakes on AWS, and we have done that for a number of customers in the healthcare, finance, education, ad tech, and media space. We provide a one-team model where agile teams with Scrum work together with you and the customers like you to build the data platforms, data pipelines, and data strategies for your company. When you work with North Bay as an organization to architect your data lake, what you get is, first we start with developing a strategy to address your short-term and long-term business needs. That may be a 4 to 8 week phase where we help design the data lake pattern and the architectural blueprint of the solution, as no one-size-fits-all exists. Then we move on to quickly build the foundation of that blueprint with you within that phase to help you get started quickly, and in subsequent phases then migrate your workloads and your data over to your data lake-based platform. We've helped a number of customers move from the old world, legacy world, on-prem world to the cloud. We call it teaching old data new tricks. It's the same data, but you can do a lot more with it in a more flexible manner. We can talk about one public case study with Eliza Corporation, where we as an APN partner help them build their data lake-centric data platform on AWS. A little bit about Eliza Corporation. Eliza Corporation is in the healthcare engagement business. They help their customer as the business of healthcare moves to pay for performance. They help people like Blue Cross Blue Shields of the world in terms of doing outreaches for adherence, prevention, condition management, brand loyalty, and retention. Eliza Corporation does order of magnitudes of 300 million outreaches and interactions per year. Interactions and outreaches have the form of IVR outbound calls, SMS, emails, and other channel. Each outreach is a series of question, response, decision tree. Did you visit your physician in the last 30 days? Might be a question with a yes-no response as an answer. This question response pairs type of data is coming in at a very high pace and at a very high volume on a daily basis. In addition to this type of data, Eliza also had other data sets, including electronic medical records, pharmacy data, enrichment data, and so on in their enterprise. Not only that, Eliza Corporation had a lot of diverse needs in terms of consumption, query patterns, and usage on that data. For some group of stakeholders, it meant bread and butter reports that they need. For others, it meant ad hoc questions that need to be answered on demand. And yet for others, it meant machine learning and predictive workloads for their business. When we helped design the data lake-centric architecture for Eliza's next generation platform, the goal was to build that next generation. As Rahul also alluded, one of the key features for an S3-based data lake on AWS is that you are able to decouple storage and compute and processing, giving you a lot more flexibility. Just to mention as an aside, that's not the case if you were dumping all your data in HDFS. In that case, you may call it a data lake, but you are still coupling compute and storage. You don't get the benefits and advantages. Another goal for designing this architecture for Eliza was to give them the ability to process their current data, but also enable them for future data sets and data streams. Eliza operates under a regulated environment influenced by HIPAA and other regulations. So considerations of obfuscation of data for dev and test system with special filters while data is passing through to decouple PHI from PII, to evaluate which managed services with AWS are covered under the BAA and which are not, and if not, then take appropriate measures. The goal of the platform design was to enable fast ingestion and storage of that data, allow for both real-time and batch-oriented processing. Of course, data lake does not equal to open access. One of the key components, as Raul mentioned, is to encapsulate your storage with access entitlements and governance. And lastly, one of the important goals for this architecture for Eliza was to enable self-service and increase that for their end users. As we implemented that, we did realize quite a number of benefits. I'll briefly mention the hub and spoke model for loading data into the platform and ingesting and processing it on the other side provided for a streamlined way of working. And that resulted in a lot of reduction in manual processing that human FTEs needed to do. In fact, Eliza realized anywhere from 30 to 40% reduction in manual effort with that. It resulted in improved business agility. Their Eliza client portal that their customers actively use got updated in near real time rather than the daily basis that it was being done before. Of course, the cloud and AWS gives you the ability to scale resources on demand and do cost attributions to business groups. They also reduced their time for what they call client analytics from weeks to hours, and overall resulted in a much more flexible, scalable platform for them. I'll spend a little bit of time going through the architectural pattern that they ended up with. And this is sort of, although there's not a one answer to all, but this demonstrates the high-level reference architecture for building a data lake on AWS. It reads kind of left to right, where the data coming in starts from the left and ultimately is kind of getting accessed and consumed on the right. We have both real-time sources of data that are pushed into a Kinesis stream and batch data that lands on initial stages of S3. For their NOC and operations, they even used Kinesis analytics for near real-time analytics. All data coming in goes through a data quality, governance, and metadata cataloging layer. This is powered by DynamoDB with Spark streaming jobs moving and transforming the data as it lands into the data lake storage. The central piece of the storage is, of course, S3 with lifecycle management based on regulatory needs onto Glacier. This whole thing is encapsulated in an API with AWS API Gateway. And the catalog is kept in a combination of DynamoDB and RDS. This provides a UI for data discovery through cloud search, for searching what's in your lake, and a UI for administering entitlements and access privileges. Now the real interesting part is on the right-hand side, where depending on the consumption need, for example, through an EMR, Presto, combination, a SQL interface was provided for their client portal to be updated. A Redshift-based enterprise data warehouse was built, fed through EMR ingestion again, EMR processing to feed some of their other needs. A Hive interface for their SAS-based machine learning statistical workloads, and other consumption patterns with third parties, all while the operational monitoring and auto-scaling is provided. In summary, the real benefit that building a data lake on AWS that you have is that you can streamline your ingestion to be fast and be able to get things in without worrying about schema on write, and then be able to utilize that with schema on read semantics as you need. I'll turn it over back to Rahul.
Thank you. So now with that, let's just talk about the last benefit of data lake, which is AWS provides you the most complete platform for running any sort of big data workload with whatever size of data you have. For instance, as we mentioned that regardless of the volume, velocity, or variety, you could use workloads such as Redshift for data warehousing, Amazon EMR for managed Hadoop clusters, Amazon machine learning for running machine learning algorithms, and Amazon QuickSight for quickly visualizing and analyzing your data set. The biggest advantage is that if your data is in S3, all of these services natively integrate with Amazon S3, so you don't have to worry about moving or transferring your data into any of these services. These services have features which allows you to readily consume your data set in S3. But not only that, each of these services could be scaled independently irrespective of how much of data you have sitting in Amazon S3. For example, even if you have petabytes of data sitting in S3, if you only want to analyze a few terabytes of data, you can create an Amazon EMR cluster or a Redshift cluster which can only work with that data set. You could use Amazon machine learning to build a model and train that model on a subset of data set, and each of these clusters, each of these services could be scaled independently irrespective of how large your data sets are. And that model provides you with many options to build a complete set of data services, for example, analytics, processing, or even machine learning algorithms. And with that, now I would like to invite Mick Bass, CEO at 47 Lining, to talk about the last benefit of building a data lake on AWS. Mick?
Thanks, Rahul. Thanks everyone for joining today's webinar. I'd also like to thank Cloudwick and North Bay for sharing their insights and contributing to this truly exciting industry transformation. I'm Mick Bass, and I lead 47 Lining's team of AWS solutions and big data architects. We're an APN advanced consulting partner with big data competency, and we help our customers build solid bridges between the business value that they seek and the analytics technologies and architectures that we've been discussing here. We help our customers at each stage of their data lake journey. We'll typically start with an initial high-value analytics use case, validating this atop a data lake foundation. Then we help our customer build, harden, and launch their production data lake, and once launched, we'll help them manage their ongoing AWS and Agile analytics operations so they can maintain their focus on how they generate value from data to support their business. It turns out this focus is really important because most of our customers establish their data lake in a way that's expected to be self-funding. Data lake efforts are often tied strongly to revenue upside, to a particular business initiative, or otherwise directed towards direct business benefits. Proving value at every step is really critical to our customers' success. Here are some examples of the value sources that we've seen with our customers, and we found that these are actually relevant across most industry verticals. The work that we've done with the Howard Hughes Corporation is a good example of this journey. They sometimes describe their business as SimCity in real life. They develop projects that span thousands of homes and condos, millions of square feet of office space, and multi-tenant retail shopping destinations and experiences. As you can imagine, there are lots of opportunities to leverage data to create business value within this setting. with the data lake approach, we can combine multiple data sources to increase pricing transparency. We can optimize the mix of retail tenants in commercial spaces. We can increase the depth and quality of qualified leads for purchases. And we can make real-time offers to consumers in retail settings. Our initial solution with the Howard Hughes Corporation spanned large-scale data ingest, fusion of multiple data sources, feature extraction, and creation of a machine learning model to enable predictions for purchase propensity based on historic actuals. Their results were particularly compelling, a 400% increase in the number of leads in their pipeline, together with rich visibility as to the qualification of those leads at less than a tenth the cost of their historic marketing and lead generation approaches. We tend to focus a lot on establishing early quick wins with our customers, efficiently laying down a robust and solid foundation for a wide range of use cases while getting initial data sources and valuable pilot analytics in place. With all of our customers, we set up these early wins with our data lake reference architecture in mind. For Howard Hughes, this enables them to continually expand their portfolio of value-generating analytics and to drive those quickly into efficient operations. Let's take a closer look at this reference architecture and why it's important. I'll walk you through 4 key aspects of the architecture. First, we'll talk a little bit about the concept of operations. That is, who are the distinct categories of actors and how do they each need to interact with the data lake? Second, a bit about AWS foundations and fundamentals. Third, a really important category of data management best practices and how we help customers grapple with the organization of the data within their data lake. And finally, we'll talk about a flexible stack of agile analytics that support different use cases driven by different business priorities and return on investment. The reason that this architecture tends to be important in customer settings is, as many on the call have mentioned, there's so much flexibility in the tools that you can bring to bear. Having this sort of an approach to help customers reason about where to start and how to grow tends to drive a lot of repeatability into this process. If we look for a moment at the outside of the diagram, we see 4 different kinds of actors. On the left, we have data contributors. These can be real-time streams from devices in the field, on-premise transactional systems, feeds from SaaS vendors, data that you've bought from data providers, data from mobile apps. It's really common for these data contributors to be diverse, to reside in multiple companies. They often span internal B2B and B2C sources. Next, we have data lake governors. This is a really different role. They're accountable for decisions about how your data lake generates value for the business, making decisions via policy about entitlements, who should be able to contribute, who should be able to consume, which analytics should be able to access which data, and they're accountable for managing the cost footprint of your data lake and its allocation back to business value. Finally, we have data consumers. Data consumers, they're diverse as well. They might be sophisticated data scientists who need direct access to manage data sets in your data lake. They could be consumers of published data using standard BI tools, or they could be B2B or B2C data ecosystem consumers who need highly available access to published data through an API. Understanding each of these categories of users and their needs helps us to optimize their interactions with your data lake and refine your data lake's roadmap. I want to talk just a moment about AWS foundations and fundamentals. One of the really cool things about AWS is it provides you all the tools that you need to manage concerns like security, reliability. An important part of all of our data lake pilots is to establish a strong foundation that covers those best practices: security, enterprise connectivity, identity and entitlements management, monitoring. Many of our customers, they lean pretty heavily towards their particular data and analytics use cases, and some of them are relatively new to AWS, so getting these foundations in place efficiently drives down their risk while speeding time to demonstrated value from analytics. Now let's look at the center of the diagram for just a moment, and we'll talk about data flow. We found that designing your data lake to support these 3 different categories of data really helps to increase the analytics agility that your team can achieve. First, raw submissions are all about just persisting the raw contributions in your data lake. They drive the contribution cost for data contributors almost to zero while ensuring that you can replay history as your portfolio of analytics evolves. The managed data sets in the middle are important because they're sort of like the translation. They're a progression of, from the left, very kind of vendor and device centric sorts of data formats, to on the right, very business centric kinds of formats. And so those managed data sets can be a lot more flexible than they could historically be in the data warehouse world. Finally, on the right, published data provides end user results, for example, reporting aggregates or structured drill downs. These are often tables in Amazon Redshift or highly available data in DynamoDB that's consumed by an API. The flexible stack of Agile Analytics is important because it drives throughput from your analysis team. It's driven by business priorities. You don't have to create them all at the same time. It really empowers analysts because it allows them to use the right tool for the right job, and it provides them access to a wide range of AWS big data tools and services. It decouples development across multiple teams and analysts, and it gives you a scalable model to generate value from data. Tying that all together, the result is that the data lake approach increases your team's throughput and value velocity. It really helps strike this balance between business owners and business value, IT, and analysts that can bring value to the table. It provides a solid foundation so that you can focus on analytics that get you to immediate value and then expand your portfolio over time. Thanks. I'll hand it back to Rahul from AWS now.
Thank you. Thank you, Mick. So in this session today, we talked about what are the benefits of first building a data lake, what essentially is a data lake, what we try to define. The second are, in terms of building a data lake, you can think of data lake as a virtualization for all of your data set in a single central repository. And the benefits you achieve is first, as all of our partners today explained, which is accelerated time to value and reduced total cost of ownership. Not only that, you get increased flexibility in terms of deploying different types of analytics and storing data at any scale. And then you benefit from the agility by which you could increase the throughput of your analytics team by giving them the ability to apply any type of analytics which can deliver the business insights, or they can produce the business insights much more quickly. Now, you choose AWS as a platform to build your data lake. Not only we talked about the benefits such as flexibility and agility, security and compliance, and the most complete portfolio of any type of big data applications or services. And each of our partners today, Cloudwick, NorthPay, and 47 Lining, touched in deep on how you can translate these features, these benefits into most tangible terms to build a data lake on AWS. With that, that's the summary of our webinar. And now we would move to a Q&A and answer the questions you may have at that point in time. I would also request all of the participants to take a moment to answer the questions which you see on the poll right now, and we will take the questions right and today. So one of the first questions we got was, what is the relationship between a data lake and an enterprise data warehouse? Do I have to change all of my existing BI, ETL, and data warehousing infrastructure to use a data lake? The answer to that in brief is probably no, because if you think about it, there's a symbiotic relation between a data warehouse and a data lake. Earlier, because of any reason you may have, or various reasons, you may have to cut down on the type of data you could ingest. You may have to define a schema and directly capture it from the sources, process it, and then load it into the data warehouse. You could rather change your data lake to capture all of your data from the sources itself in a much more native format and much more quickly and easily. And then your existing ETL processes could directly read from the data lake and then push it into the data warehouse. That way you could leverage all of the investment you have done by providing a data warehouse to your end consumers, yet at the same time capture all of your data in the data lake to help your businesses grow or consume the data or turn it into a much more valuable asset. The second question what I have is for 47 Lining, and the question is, how do you incorporate real-time analytics into a data lake?
So I think the key there is the use of this agile analytics paradigm, where you can actually have a process that publishes the real-time subset of your data to, say, for example, a real-time Spark cluster that your dashboard tools are connecting to. As data comes in through Kinesis, if you need extreme real-time observations, you can actually reach all the way back into that Kinesis stream and operate on data as it comes in. You can also build flexible processes where you can have a Redshift cluster that is responsible for maintaining historic data, historic, in air quotes, meaning everything that's more than an hour old, and a Spark cluster that's accountable for the stuff that's, much more recent. And then the BI tools kind of rely on the Spark subsystem for real-time information and the historic Redshift system for queries that are longer lived.
Mick? So the next question I have is for Cloudwick and Mark, which is what advantage have your clients realized from AWS data lake and data warehousing projects?
Great question. I think the most important one is really the transformation with business and IT. What we see with our customers who are working on AWS data lakes is the relationship between IT and the business really becomes very collaborative. IT is able to respond much quicker. They're able to deliver results where it may have taken a year or more to deliver a project. They're now able to deliver projects in months. So I think at the end of the day, the real transformation here is that what we're seeing is a lot of the friction that is become inherent because of the challenges that IT has working with a traditional on-premise data center model as well as traditional applications really is non-existent when it comes to AWS, and it liberates both parties to collaborate and accelerate that successful business relationship.
Mark, so the next question I have is for North Bay, which is what is the key to getting data lake projects off to a fast and successful start? Raja?
Thank you, Raul. In our experience at North Bay, I think the fastest way to start is to start small, work into a reference architecture that works for you. For example, we at North Bay offer a package service called a Jumpstart package where in a short period of time, we want to bring you as an enterprise to a state where you have answered some of the tooling questions, the basic reference architecture, and built a roadmap for implementation. And in that small, 4 to 8 weeks time, you have built the basic blueprint and lined it up for the next phases. We've seen that to be very effective because it answers a lot of questions in a short period of time and gets you as an enterprise starting quickly on that.
Thank you. So another question what we have is how should we ingest traditional SQL data into the data lake? Store it in S3 or elsewhere? I think this has two parts to the question, which is first, where should you store all of your data? Would it be S3 or somewhere else? It really depends on what is that you're trying to do. If you're trying to build a data lake, having a centralized repository is probably one of the key aspects for a data lake. And you definitely want to store most of your data into S3 as, for example, Mick also mentioned in the terms of being able to having the raw data set allows you to repeat history or retransform history as your portfolio of analytics evolve. As your understanding of your data grows, it's very important for you to have that raw data set as an asset sitting into your data lake. The second part of the question, I think, is about how do we ingest traditional SQL data into a data lake? And there are many tools, as you mentioned, for example, AWS DMS provides your ability to replicate your data from on-prem databases into Redshift, or even our partners such as Attunity provides a product called Attunity Cloudwick, which can take your data from traditional sources and keep a copy back in S3. Or even you could leverage custom implementations such as, for example, Oracle provides a product called Golden Gate, and you can connect a Golden Gate to a Kafka or Kinesis stream, which can then ingest your data back into your data lake on top of S3. Now, one of the important questions I think we're seeing time and again into the Q&A is, what is that we do about the metadata? What are the best practices for building a metadata? What are the things we could do around to make it easier for a metadata building on top of your data lake? One of the basic pattern we talked about earlier to answer that question was using something called S3 event triggers. You can use S3 event triggers and connect them to AWS Lambda functions to trigger a variety of workloads. For example, keeping an entry or keeping a catalog updated in DynamoDB, or even feeding the data back to a downstream processing system such as Elasticsearch to fully index your data. But all of these options are kind of something you have to build your own, and that's why we had our partners today talk about, for example, Mick, Mark, and Reza all talked about the benefits these partners provide in terms of helping you simplify in trying to build all these different components of data lake from the various services, from the various features which AWS provides. And that is one way you could leverage it. There are some other ISV solutions or technology partners also who provide such services, such as waterline data, or there are open source frameworks, for example, which allows you to take advantage of data, for example, Apache Atlas or anything else, which you can leverage to build that holistic view of the metadata. And with that, we'll have last question because we're running on the hour. And I think the question says that, do any of the partners have experience with FERPA in higher education? I'm not sure what FERPA means, but if Mick, Mark, or Raza, if you have any experience, I would let you just chime in.
This is Raza with North Bay. We do have a good amount of experience with ed tech and higher education, and we can certainly take this offline and talk more about it.
Great, thank you. That's all. Again, thank you everybody for attending the webinar today. We hope that you enjoyed the webinar and got to learn about building or architecting a data lake on AWS, and you learn the value our partners provide you in helping in collaborating with you for building that data lake easily and successfully on top of AWS. Thank you again, and we again appreciate Mick, Mike, and Raza to help us in translating the value of building a data lake back on AWS to our customers today. Thank you, everybody.